This is Avery, and we're going over the final code now. I'll just give a brief overview of what our program now does, and then we can start diving into the tasks from there. Okay, our topic was solar energy, making it more economical. So there's two main things that our code now does. We'll get into how it does it later, but this is just an overview of what the code does. So the first thing is the user will select a state, and we'll give them information based on which state they selected regarding solar energy. So the sunshine hours of the state, that means how many hours of sunshine the state receives every year. And we do a lot of things with that data specifically. And the other thing that our program does is you can calculate how much profit you can make if you have solar panels and you sell it back to utility companies. So those are the two main things that our code does, and now we'll get into how it does it. So with our first task, this goes towards our second goal, which is calculating a profit. So we first start off by asking the user for their energy usage every year. So this will be talked about later on whenever we get into the functions, but for this task, it just receives the input, and then we have validation here. It uses a while loop and if statements just to make sure that the user can't enter something less than 0 or 0. They have to use some energy throughout the year. And then we have the user enter the surface area of their solar panels. That'll also be used in calculating the profit. And then next, in the last part of task 1 is just choosing which state. You can see here on line 69 how we have a program control set up. So that just will repeat it back whenever we're, if they want to select more than one state later on. So you can see starting on line 72, a menu will pop up and the user will select a state. And we have a validation right below it in line 74 that just makes sure you can't exit out of the menu. And so our data set isn't perfect. And in line 81, we have it, what this is it shows that some areas where our data set is not totally complete, a menu will pop up and the user can select another state, and we have validation to make sure that they can't exit out of that.
This is Abdullah Grafi. I'm going to go through the first output. So the first output is the profit. Here's the variable for the profit that calls the function. We have a local function here. So what the function does, the total sunshine hours for each state will be multiplied by the surface area, and the result is going to be the total energy produced per year. So in order to calculate the excess energy, we need to subtract the total energy per year by the energy usage of the user. Then the result will be multiplied by 4 cents, which is the price of selling 1 kilowatt hour of energy back to a utility company. And that's the result is the profit. And here is the second output. It's basically the energy reduced by each state per 1 hour. So we have a script function. So basically what this function does is divide the energy reduced per year for each state by the total sunshine hours. So the result will be the energy reduced per hour for each state.
This is Charles Kretschberg, and I'm going to be going over task 4. So the first thing that we do for task 4 is to create a new variable for the sunshine hours and test whether it is greater than 0. Then we calculate the mean and standard deviation. Then we have an if-else statement to determine whether a state is good, okay, or poor based on the amount of sunshine hours it receives per year. So the stuff after the if-else-if statement leads into task 5.
It's Paul Slode, and I'm going to be talking about task 5. So the vectors that were just mentioned are being created every time the while loop repeats, and it's creating the vector of the state names and the vector of the sunshine hours so that we can create a bar graph later on. As well, we are deleting the data for the selected state from the variable as to make sure the user can't reselect the same state. In the next task, we create a new figure using the mapping toolbox, which is an accessory to MATLAB, and it has a function called USA map, which you can create a US map figure inside of a MATLAB figure. And Hawaii and Alaska are on different layers, which actually caused us a few problems at the beginning, but we were able to get through that. Down below, we have an if, else statement that has a few different scenarios within it. Because Alaska and Hawaii are on different layers, they will not highlight in accordance to how the user wants them to. So we had to create a few separate scenarios for if the user chooses Alaska or Hawaii or both. And if either one or both are chosen, then Alaska, Hawaii, and whatever other state the user selected would be highlighted. Otherwise, just the states that the user selected would be highlighted. And this for loop below basically gets rid of grid lines and lines of latitude and longitude, which clutter up and make the map look less presentable.
So after our program creates a highlighted map of the selected states, it then creates a bar graph that allows you to compare multiple states based on the amount of sunshine hours they receive. It also outputs a TXT file that has all of these states sorted by the amount of sunshine hours they receive, along with the cost to produce solar energy for 1 year, along with the kilowatt hour output that can be expected. Okay, so this is our poster for our NAE project. I'm going to be going over test case 1 right now. So after I hit run, it asks me for the energy usage per year. And then it asks me for the surface area covered by the solar panels. Then it gives me a menu to select whichever states. For this test case, I'll select Texas. And then it asks me if I would like to repeat the selection. And it tells me the profit I would gain if I sold the excess power per year, the average output per hour in Texas, the average sunshine hours received annually. And it tells me that it is a good state based on sunshine hours. It then brings up a bar graph of Texas. And then here's the highlighted map with, of course, Texas being highlighted.
This is Paul Slode, and I'm going to be going over test case 2, where I will input the energy usage 6,500 with a surface area of 6 meters squared in the states of Pennsylvania, Tennessee, Georgia, and South Carolina. Alright, so it asked me for my power usage per year, which is 6,500 and 6 meters squared. And then I get a menu asking me for the state selection, so I'm going to choose Pennsylvania, another state, Tennessee, another state, Georgia, where it prompts me the state has insufficient production, and it prompts me to choose another state. And so I choose South Carolina, and I would not like to repeat the selection. And in the command window, it gives the profit, average output, average sunshine hours, and tells whether or not the state is good, poor, or okay for solar energy in the command window. And here it gives the map with the highlighted states. It did not highlight Georgia because it has insufficient production, and it gives the bar graph of each of the states' sunshine hours so the user can compare.